So like I said, the goal here is to give you an overview of all the parts of what data engineering. And so these are the major components of a data stack. I don't want to say that I lie, but just there's actually more stuff. There are things called query engines, so like Redis, Elasticsearch, Jupyter notebooks, machine learning stuff. Like there's more stuff, but just we only have 3 hours, and so we're going to kind of focus on the really core pieces. And so we're just kind of go through what all these pieces are, like how they fit together. I'll talk a little bit about specific pieces of software in each of them, but really like we're not doing demos. This is just to give you an idea of how everything fits. And so the first step in a data platform is acquisition. Is like you got to get some data. And so for marketing and sales stuff, that's been CDPs. Segment, Snowplow is an open source version of similar to Segment, as well as Honeypot. I think there was a speaker earlier today or tomorrow from them. And so these little things will do like instrument your website, instrument your mobile app, and kind of tell you what your users are doing. Google Analytics also serves that role. Your Facebook, HubSpot data. You might also, if you're dealing with like server monitoring, those can be server logs or metrics, things coming like from Datadog. Sometimes, you're going to just go out and crawl the web for like arbitrary data. And so I had a customer that does, they work for a large like food service distributor. So everything from like napkins to carrots. And they were crawling the web, scraping menus to figure out what dish, like the ingredients in different restaurant dishes, to figure out how to what products to prioritize selling. The other thing that's really quite common that almost everybody deals with is that data can come as a byproduct of transactional systems. So those are your internal databases that are like driving your web app. And so like you'll pull the data out of that. Like, if you've got a chat forum, you'll pull the messages out of that. I forgot IoT. There's like lots of nice like IoT solutions. You've got a sensor and, it kind of sends data off. But like everything else, you're going to have to write some code, which is fine. Sometimes this is not your problem. Like the data is just handed to you. And like, you don't have to worry about this at all. Like somebody's like, hey, there's some CSV files on S3, go nuts. And you don't have to worry about getting it. But this is kind of where you interface usually with your applications team or your mobile app team to kind of like say, hey, we want to start doing a data program, like instrument the mobile app so we can figure out what buttons people are clicking on. So once you've acquired that data, you then need to ingest it. And, this is what we've been calling ETL. The goal of it is to get data into the platform. And we'll talk about a little bit more. Like, I think ETL is a bit of a legacy term. Transform has kind of become its own layer. As we've moved to ELT, and say like, and I really think that just, like I said, when I think about this as just ingest, is just get the data in there, whether that's into your data lake or your data warehouse. And you really wanted to have your raw data with minimal cleanup. And so that's absolutely essential because it's like your original source of truth. And so if something goes wrong and you need to rebuild it and you have made a bunch of modifications on your way in and you don't have that raw data anymore, like what do you do? And so I had a friend was a head data ops at a company called Carfax. It's a used car sales analytics company. And he said, this is, 4 or 5 years ago. He's like, I have 10 terabytes of data. If somebody forgets a column or like misparses a field, what am I supposed to do? Reload all of that? Like that's not feasible. And so he said, like, look, just as raw form as possible, like just get it in your platform and then clean it up later. The one exception I make to this is that around PII stuff, is that, maybe if you've got social security numbers or like medical data or whatever that just really should not be in your platform at all, masking that or hashing it or just dropping entirely on the way in can be kind of an easy solution. I find that I often tend to actually use multiple tools to do loading. And so I'll use what I call native loaders when it's possible. So Snowflake has a tool called Snowpipe where you just point it in an S3 bucket and it just loads the data for you. That's really fast. It's really cost effective, but it's limited, right? It can only deal with CSV files. And if you need to get data out of other platforms like APIs or like say like the Facebook ads, that's when you're gonna use something like Meltano, which used to be called Singer, Airbyte, Fivetran can do some of that, where basically you're talking to third parties and they will load that into your warehouse or your lake. And so, like I said, I'm a big fan of multiple choose the right tool to fit your needs. There's not like one solution for everything. Okay. And so the first place you're going to take your data is put it into a data lake. I kind of think of this as like a puddle of unstructured data. And we'll talk a little bit more about that in the data architecture set at the end. And this serves like 3 different purposes. And so basically we're talking like, this is your cloud storage, S3, Google Cloud Storage, Azure Blob Storage, stuff like that. And so it's like the landing zone for your incoming raw data. And so like, you're just going to get that raw data and just go, okay, like we got it in our system. Now we can figure out with it. Once you have that saved, that's your source of truth for like rebuilding in case something goes wrong, or if you want to make changes or try different things, like you have like the original version that you can operate in. The data lake is also the source and destination for processing pipelines, things like Spark. We'll talk about that more in a second here, where they are kind of better suited to operating against cloud storage than against a warehouse. And then the kind of final use is that like data lakes tend to be like your scratch space, like your temp files in a distributed data system. So, we have some job over here and it's got some output file. We need to get it to some job over here, whatever, like that's going to go on your cloud storage. Yeah. Okay. So the next kind of big thing, and what I'm guessing a lot of people spend a lot of time on working in, is their data warehouses. And these are like the workhorse of your data platform. And so they are very appealing because this is like massive data solved. Like they have solved this problem in a way that's very accessible and scalable, and that is much better than sort of hand rolling and stuff. And so the flip side of that is that you're limited to SQL. As basically like they're like SQL driven databases, and that's a plus. SQL is great, but it's limited to what you can do. But for that trade off, you get a lot of wins. And so, like I said, that scalability. It's also the back end layer for BI systems. Almost universally, just talk to warehouses. This is also where, like I said, like I tend to think of it as ingest as opposed to ETL or ELT. Like this is where transformation happens, and that's for 2 purposes: both like cleanup and like normalizing your data. So like okay, like maybe some like some things come in and it says 0 the string as opposed ZERO as opposed to number 0. It's kind of a dumb example, but like okay, let's turn that into numbers. Like let's put everything we have medical records from 3 different sources, let's turn those into a common schema. And so like that's one of the functions I find in warehouses. And then analytics. And so once you have those cleaned up data, to then sort of ask questions on top of it and kind of do transformation, stuff like that. And so Redshift, Google BigQuery, Snowflake, Azure Data Warehouse kind of fit in this bill. If anybody's using Databricks, they do have a data warehouse thing. It's basically just Spark, which is it's weird. Databricks is weird. uh, this is where we'd be using DBT. And so, like I said, I'm guessing, given the audience here, most people are familiar with DBT, so I'm not going to spend too much time talking about it. But just this tool, I mean, has just transformed the data landscape, and there's a lot to admire about it. There's, like I said, like there's plenty of free, like really good tutorials. But just as a software engineer, this is what I love about DBT. Is this like I've been writing SQL since 1998, and this is the first time you've been able to reuse it, like write little snippets, like the way you would write a function in Python, and then reuse it for different purposes. And so, like, I look at the difference between these two things, and it's like, oh, let's say we want to add another payment method. Like, that's a one string change with DBT versus, oh wait, you've got to re-implement all this logic for each time. And so I like to joke, I think I've implemented half of DBT 6 times in my career, like 6 different, and it's so wonderful. And I think this is what has really enabled analytics engineering as a separate discipline. And it's really, like I said, becoming central to the data ecosystem, where just everybody are building both DBT plugins as well as sort of like third-party products that operate around on it. And so, yeah, that's been really, really, really powerful. If anybody's got web experience, like I think of DBT as playing the role that Django did for web apps, 10 or 15 years ago, where like Django is a framework, and then there's like hundreds of plugins that you can kind of put on top of it to make it do more stuff. Yeah, and so that's pretty cool. Okay, so other parts. So data pipelines, this is kind of like my catch-all term for all the like non-SQL processing you're going to do in your data platform. And so this is mostly things like Python scripts, and it's going to operate in data frame APIs. That could be with pandas, can also be with R. Mostly these will operate against the data lake rather than the warehouse. Is like pandas doesn't really know how to talk to a warehouse. Like you got to get the data out of your warehouse into a CSV file on the lake, and then you can do stuff. And so, like, why do we need this? Is because as great as SQL is, like, it can't do everything. And so this allows us access like a whole ecosystem of existing library code. Yeah, and just kind of do more complex logic than you can do just in SQL. This is also like where machine learning happens. And so that's both inferencing and training. And we'll see a little bit more about that, how that looks later. But just, yeah, like that all of this I kind of think of as just like everything else that's like computationally oriented besides SQL. And I found in my experience that most of the time, this is the result of somebody wrote a Jupyter notebook. And now we need to like turn that into a production quality app. And so, like I said, things here like Spark, Pandas. Spark's a distributed data processing framework. Pandas, scikit-learn is the machine learning model. And so as a data engineer, like with regards to machine learning, like I kind of stop at scikit-learn. And when you're getting into things that are like distributed training across like large clusters or like hundreds of GPUs, that's a little more specialized. That's kind of more like machine learning, ML ops or machine learning engineering. But like as a data engineer, I need to provide a platform that can kind of support those operations as well, if they're needed. Okay, catch my breath for a sec here. All right, and so we've gotten our data loaded, we've gotten our warehouse, we've cleaned it up, we've ran some analytics, and it's like, okay, that's all good, but like, what's the end goal of that? And so I tend to think of those as this is the outputs. And so these are the human readable results of a data platform. And so those could be static reports, like that's like your level 0, level 1 on your self-serve. So those are PDFs, Excel, also dashboards. business intelligence tools, and so those are a little more dynamic. Whereas like a dashboard is it's just fixed. Like you can say there's no drop downs, there's no like parameters that you can change. It's just you just get what you get. And BI like is a user-friendly GUI for kind of doing some of the stuff you might be able to do in SQL, kind of a little more interactive and exploratory. Yeah, also exports. So a lot of times I've found that like one of the things we also need to do is put data out into other formats. So like, hey, we've done a bunch of processing, and then we need that as a CSV file or a JSON blob that's going to go into some other job, or maybe get handed off to a partner. Say, oh, hey, I owe, my ad partners a report on all the web traffic we got. So you're going to do a bunch of work to calculate that and then hand them that file. Machine learning models, so the result of training kind of also mentally fit for me here. Right. So like we've done a bunch of processing. At the end, we get this artifact. And like whether that's a CSV file or a machine learning model, like that's an output. Tableau is the classic BI tool here. I will straight up say it's 2022, and if you were building a new data platform, there is no reason to use Tableau. Like if you have an existing infrastructure or users are familiar with it, like that's great, but just it's expensive, it's clunky, it's very awkward. Like I don't know, somebody correct me if I'm wrong, but like to develop new BI views, like it requires a desktop app, like the pricing is extremely expensive. I just kind of like enough with Tableau. Apache Superset is a really sweet open source tool for this. Other things people seem to like is Metabase, and then also stuff like Grafana is just your dashboard. So like you can code up a dashboard, but there's no widgets, there's no controls, nothing like that. Yeah. So okay. All right. So the other kind of thing we can do is like once we've done all this analytics and stuff is what's called reverse ETL. This is what Census does. And so this is the idea of moving beyond just analytics is to actually operationalize the data. So analytics would let you say, hey, like we looked at this and we're like, okay, New York looks like a good market this month. Let's buy some more TV ads. But like there's a person making that decision. Whereas with reverse ETL, it's like you're actually trying to close the loop. And so like to fully automate that decision-making process. And so my favorite example of this is like maybe you pull data out of Salesforce, hydrate it or enhance it with your internal stuff, maybe combine it with Zendesk, figure out what your hot leads are, and then feed that back into Salesforce so that your sales reps can then like know actually who to go contact. Ad targeting could work the same way. All of this is to say, this stuff is hard. And right now the options are not very many. There's Census. There was an open source project called Grouparoo. They got acqui-hired by Airbyte, which is an ETL tool on the front side. And the product's now defunct. But it's still up on GitHub, and if you were a Grouparoo user, like that's fine. Like you can continue to use that, but you're kind of stuck with it as opposed to like they just went out of business. And then the other option is hand-rolled Python. Like you're writing code to do this. And so I'll tell a little story here about what makes this difficult. So something like Salesforce, this is relatively easy. Like Salesforce has an API where you can just be like, here's a really big CSV, just go import it, right? That's pretty straightforward. Where things get tricky is where if your destination is another API. And what makes that hard is the data volumes coming out of your warehouse are so large that you can like hammer your target. And so I actually, oh my gosh, 4 or 5 years ago, worked on a project where the mobile app, kind of pretty standard stack, acquisition by segment, loaded into BigQuery with Fivetran, and then they wanted to push, they ran a bunch of analytics, and then they wanted to push that data into Braze, BRAZE, which is like all-purpose push notifications platforms. So emails, in-app notifications, and stuff like that. And the only way to do that was Braze had an API where you could, put in your users and then add properties to them. And so I wrote some Python code and I straight up broke Braze. Like I broke it. Because we were hitting them with so much data that like there was some problem in their backend system and we started getting errors. And basically like the way it was supposed to work is if you had a user, you could add property, and you said, hey, set the property A to value 1 and property B to 42. You were supposed to be able to do those and they would be additive. So like you could do one after the other and then we could combine. And what it turned out is that there was a bit of what's called a race condition. So like if you did those two things too quickly in sequence, one of those properties would get dropped. And so like we had all these rows coming out of BigQuery and I was just slamming them at Braze. And we started to see data was getting missed. And that was fun. It actually turned out, this was hilarious. I wrote like a proof of concept script to figure out try to figure out what the problem is like, is it on our end? Is it on their end? And I just like wrote a script that just generated data and just hammered their API. And my client was in Europe and I ran it. I'm in New York time. And I ran it in my morning. So Europe's afternoon, and I was able to provoke this bug. And then I ran it the next day in my afternoon, so like 11 or midnight in Europe time, and everything worked fine. And then I ran it again my next morning, and I broke everything. And Braze, they were using, like I said, it was a European company, and they were using Braze as a EU server. And so the problem is that Braze's servers were overloaded. It depended on how much traffic they were handling. And so I think we eventually followed a bug report up with them, and then we made some kind of mitigation on our end. But like I said, this is hard. And right now, like this is one of the few places I recommend that people actually go with a proprietary solution. Doing data verification across platforms is pretty tricky. So like, how do you make sure that all of the data got into your target correctly? Like that's actually quite hard. And so I think this is a really exciting space. I think this is kind of really like obviously BI is not going away and analytics is, but like this is the kind of automation that I think over the next couple of years is really going to kind of start to transform the power of data apps. That said, I'm not sure this term is going to stick as reverse ETL. Like I'm not sure what we call this yet, but just reverse ETL is like a little bit of a funny term. It's like, okay, like what, like, well, it's not ETL. It just, I think it's going to wind up meaning a couple of different things. And so like, I would not be surprised to see if this terminology changes. What do I think so? I don't know what it should be called yet. I'm not sure. I'm not sure. It's sort of a weird concept. I've thought about, if I don't like ETL on the front end and that's ingest, is this XGest? It's just not, I don't know. Like I said, like I think this is really, really evolving, and the use cases for sort of automating the products of your data platform are still like, we're still just figuring out what we can do with that. And so, like I said, it's just, this is the fun stuff for me. I like working on things that aren't solve problems. So, Okay, so like those are all the major components, and you can kind of see them here. And so the question like that is coming as a software engineer who like worked on all the web stuff is like, how does anything happen? It's right. So like there's all this data floating around and there's all these different jobs to run, and maybe there's like DBT tasks and SQL scripts and like pandas stuff. Like what actually makes it go? And so in web apps, like everything's a request and a response. User clicks a button, a row gets inserted into the database, like a page gets returned, an email gets sent. Like what is the initiator of action in a data platform? And so that is what is called orchestration. And so this is like the arrows in the data diagram, right? And so as you kind of draw out these kind of things, like you start to see, like that's really important. Like it's really like we have all these different services, like storage engines and kind of different processing parts, but like what actually connects them all? And so like this is really, really key. Like I said, like your orchestrator is what like drives the action. I like to think of it as like the recipe for baking your data cake. So it says, okay, go to the fridge and get out the eggs. That's acquisition. Like crack the eggs in a bowl and add the flour. That's ingest. Mix everything, like that's, maybe that's transforms or whatever. I'm stretching things a little bit. But like thinking of orchestration as that recipe of sort of how all of these parts fit together. And so the events that actually cause things that can happen are three. So the passage of time. So we just say, hey, we want to process all our data. We want this report to run every hour. Like there's new data showed up. Right. Like new data shows up like automatically, like some new files showed up on S3, like, hey, go process them. Just the passage of time, we can say, hey, just once an hour, update the system, generate a new report, we're good. Or doing it by hand. That's it. Like, that's it. Like, those are the only way things like that is actually going to cause something in your data platform to happen. And so here, let's pop up the poll real quick. And so I'm curious to see like what people do for this part of the problem. Parker, Trevor, can you throw the poll up? And so like, how do people run their jobs? Are using cron scripts. Like I've seen people, they just do this by hand on their laptop. There's a kind of couple different options here, and just like what are people using? Okay. And so, since this seems to be the dominant answer, if people who are answering other, would you put that in the like what you're doing in the chat? Okay. Cron the scripts. Okay. Cool. Give people a second here. So yeah, a lot of cron users. Right. So we'll hop back in a second. So like, right. Yeah. So cron is not so awesome in my experience. And so like I said, as like when you're running these with cron jobs, like you're basically, you just got like, if you have a bunch of different steps or a bunch of different scripts, you kind of just got to time them right. Right? Like, oh, Jen we'll talk about this in a second. You just kind of got to time everything right. Like if you have some script that does ingest and then another one to transform, and those are separate cron jobs, you got to leave enough time for your ingest, for your ETL script to finish before you run your transform. And like, what if you have a lot of data today and it's slow? And so it's kind of a little bit fragile in that regard. You're also like losing out a lot of the advantages. I mean, like debugging these things is really hard. Like there's not awesome, like you got to go find all your log files and like what actually happened, stuff like that. Kind of similarly, like AWS like I've seen people do this with what I call a mess of lambdas. So like you can write like AWS lambdas to run a little bit of code, and then when one finishes, it kicks off the next one. You have this kind of whole big big graph of stuff, and like that's also pretty fragile. And so all of these solutions, like what you wind up building is you're building parts of a proper orchestration platform. Like it's like a home rolled one, and you're just missing out on a lot of features. And so the most popular one right now is Apache Airflow. So Airflow will deal with all of these things you want to do. So like it's got a really nice dashboard, and you would say, hey, show me all the runs of this job, and you can say, oh wait, this one failed, and you can click directly to the log files that for that job, and you can kind of see what's going on. It can run jobs on a schedule. They have sensors, and so Airflow can do things like, hey, watch a database, and when new rows show up, kick off a new job. Prefect, who I think there's also some speakers here today, also does this same thing with Dagster. Airflow is super nice. There's this whole set of providers, which are basically like plugins. So like you want to watch for files on S3, they got a thing to do that. You want to kick off a Spark job, that's like, they got something to do that. I mean, there's like hundreds of them that you don't have to write code yourself to do. That said, operating Airflow is I have a whole other 3-hour workshop basically just on this slide. Operating Airflow can be pretty challenging. Astronomer is is a company, their main developer. They have a hosted solution. It's excellent. I highly recommend that. I was pleased to see somebody said Jenkins. Jenkins is an old school CI/CD tool. And yes, you can use it to do this also. But like I said, there's better options. And so what does the orchestrator actually do? And so folks have may encountered this term, a DAG. And so this is the model for how orchestration works. And so this is the one piece of computer science I teach. And so just hang me here with a second. And so a DAG is what's called a directed acyclic graph. And so a graph is like this thing on the right. And so it's a bunch of nodes and edges. The things like with lines or bars, those are technically called plots or charts. But this is like the core organizational structure in a data system. And so it defines how like data moves and like the between like, oops, sorry, I'm going the wrong way. Kind of between those different steps. Like this is a very simple DAG, right? That we're looking here. Like, okay, it's like one step after the other. And so it's going to define the sequences of edges. And so like I said, a graph is composed of nodes and edges. Like the nodes are your operations. So that's like your A's, your B, your C, and then the edges are the lines between them that connects them. And so the most common graph people are familiar with is the Facebook friend graph. And so, right, like that's the links between all the kind of different people's friends. So directed means that the arrows go one way. And so that's more like Twitter. So on Facebook, a friend relationship is undirected. Like if I'm your friend, you're also my friend. It goes both ways. But on Twitter, if I follow you, you may not follow me. So like there's an arrow direction. That's what makes it directed. And then the acyclic means is there's no loops. And so that doesn't apply to Twitter because, I could follow Parker and Parker can follow Trevor and then Trevor can follow me. And so that's a loop. And so in a DAG, like in your orchestration system, everything's going to go one direction. You may have like 6 different things that come together and then, they spread out again, but it's all going one way. And so examples, like real world examples, I think I like to think of this are supply chains. And so, you dig the iron ore out of the ground, you send it to a steel factory, the steel, you make some steel, the like raw steel is sent to a toy factory, the toy factory goes to the toy store, and then it goes to somebody's house, but there's no cycles. The toy never goes back to the mine. It never goes back to the iron mine. DBT models are a DAG. And so if anybody's ever looked at the lineage graph in DBT, that's a DAG, is right. So like you have your base models, and they, then some views that depend on them, and kind of so on and so forth. And then finally, package managers like pip also implement the DAG. And so when you say install DBT, it goes and basically does this backwards and say, okay, what are all the dependencies? Like DBT needs, TQDM, and it needs, I don't know what else, date utils or whatever. And so those form a similar kind of data structure. Yeah. And so at this point, you're saying like, wow, this all sounds so complicated. Like, why do I need this? My cron jobs have been fine. And so, like I said, this is the world's simplest possible like data platform. This is a little more realistic. And, this is even pretty simple by comparison. And so just, you could have, there's maybe a dozen nodes on here. Like, run-of-the-mill data, you could have, 2 dozen of these things, or 3 dozen of these things, or it's just, if you're an enterprise, like hundreds of these. And so having a more sophisticated tool that helps you manage all these relationships, that does things like deals with retries, manages the dependencies, gives you a UI for exploring and debugging, and like historical tracking of how long did that ingest job take, stuff like that. Can also run things in parallel. So like if you're ingesting, like on this stuff, you're ingesting from Postgres and CSV, those are independent tasks. And something like Airflow will just figure it out for you that those don't have dependencies and can be run at the same time. And so they're more efficient. And so on the whole, like this is just a way, way more powerful set of tooling than you can get out of cron jobs. Okay. And so this is a good time to talk a little bit about some design principles. And so the first one I like to think about in data systems is like rivers and refineries. And so basically, like that's like an oil refinery on the right, and just like a river valley on the left. If your data system looks like a refinery, it's gonna be slow. If there's like it's gonna be slow. It's gonna be expensive. If there's like a million pieces that all feed into each other, like that's way more difficult to and way more expensive to run than something. Ideally, like you want a couple of jobs that all feed into each other, like the Mississippi. Like there's a couple of different rivers, and then you get like one big output, and kind of all goes in one direction. And that's just like a lot faster, a lot more efficient. That said, sometimes the business rules say that like, well, okay, but this is what we have to do. It's like we do have to bring together data from like 6 different sources, and then do some analysis on it, and then maybe pull in some other stuff. And so the trick there is to just make sure you do the expensive things once. So if you have like a really expensive computation to run in DBT, like materialize that, like as for technical reasons, like just like bake it off and like save that data set, even if it doesn't have real business meaning. Like rather than having to recalculate a view on the fly that's slow every time, like do that expensive thing once. Like, in this thing, like if you have some Spark job, like run that once, save the results. And then I guess just, I don't know, we'll throw 2 more principles here, and then I'm going to take a proper break. I'm a really big fan of data being immutable and immortal. So like no updates, like no update statements at all. Updates are for disaster recovery. But as in your day-to-day operation, you should never overwrite data. Everything will be much simpler. Like get it in there and then like process it. And then if you have some new data, like append that. But like, this gets back to some of that reproducibility thing. It's like, okay, like we ran the report on Monday and it's now Thursday. Something went wrong, and it took us 2 days to figure it out, like to realize. like if you don't have access to the state of the world on Monday because you overwrote the data, like you can't debug it, right? Like you can't replicate the run of that job again. Yeah, and so like I said, like it just makes everything simple, makes everything simpler. Storage is cheap. Like storage is so cheap, and it's just the putting a couple of extra bytes on S3 or even certainly BigQuery like does not cost much, and it just save everything. Like be a pack rat, be a hoarder, save everything, don't throw anything out, don't overwrite it, like write it once and then kind of do what you need to do downstream. And then this last bit about matching queries to storage, we'll talk more in a little bit about a couple minutes.